Welcome to Chapter 8, Logarithmic Functions. So you should have already done your exponent laws and understand everything that happens with exponential functions and graphing those before you attempt to do anything with logarithms. These two are very much attached to each other. And actually, logarithms were invented first, and then exponents were invented afterwards when we were dealing with logarithms. So we're going to start in Understanding Logarithms, section 8.1. But we are going to go back to exponents first because you have more of a base knowledge in that. So label the components of the power. So we have 4 exponent 3 is equal to 64. So 4 is our base. 3 is our exponent. And then 64 would be the answer. Now the generalization of that then is we usually use b as our base. We'll use e as the exponent. And again, a is our answer. So they very much make sense of what variables we'd pick there. Now when we look at the logarithm, you can see that these are just mixed around a little bit. So we have log base b of a equals e. So our answer in this case is our exponent. And we generally use logarithms when we're looking for a missing exponent or the variables in the exponent. We have our base b and it's in the subscript. And then our answer is in front of that. Now, sometimes that's also called an argument. Now, we have something called a common logarithm, and that's base 10. So if you look at your calculator, it'll just say log, and you have to assume that that is a base of 10. Meaning, if I go and rewrite this as an exponent, it's actually going to be 10 to the power of x equals y. And the same, when we're doing it algebraically, if it's base 10, we just write log. You don't need to write that 10 there. So let's jump right into some questions then. So we have evaluate some logarithms here. Now the easiest way to evaluate this at this point is going to turn them back into exponents. And so we have 2 as our base. Now we don't know the exponent, so 2 to the power of x is equal to our answer, our argument, 1. Well, 2 to the power of what is equal to 1? Well, 2 to the power of 0. So therefore, we have actually that log base of 2 of 1 is equal to 0 then. Okay, let's try another one. So we'll turn this into a power. So 2 is our base. We're looking for some exponent is equal to 2. Well, 2 to the power of what is equal to 2? Well, 2 to the power of 1. So therefore, log base 2 of 2 is equal to 1. Let's do another one. Again, base 2. And we have a missing exponent. It's equal to 4. So 2 to the power of what is 4? Well, 2 to the power of 2. So therefore, log base 2 of 4 is equal to 2. Now we can see a pattern here that's occurring. This is doubling each time, and the base is staying the same. So we can probably already guess that this is going to go up by 1. Our exponent's going up by 1 each time as our answer is doubling. And our answer is doubling because the base is 2. But let's just check this out. So we have a base of 2 to some exponent is equal to 8. Well, yeah, 2 to the power of 3 is 10. All right, let's look at the common logarithm then. So you can see there's no base here. It's just log 1. Well, that means we have a base of 10. So we have 10 to the power of something equals 1. Well, again, 10 to the power of 0 is equal to 1. Okay, here we have 10 to the power of something equals 10. Well, 10 to the power of 1 equals 10. And you can see this pattern is very much the same as the top one. So our base is staying the same. But this time, it's getting 10 times bigger each time, because our base is 10 each time. So we should expect the exponent goes up by 1 each time because this answer is getting 10 times bigger. But we should double check that. So we have a base of 10 to the power of something is 100. Well, yes, 10 squared is 100. So this is equal to 2 then. And it's going to be the same thing here. 10 to the power of x is equal to 1,000. Well, 10 cubed is 1,000. So still using those same skills, order each set of logarithms from least to greatest. So we're going to just go and do the exact same thing, but now at least the bases are a little bit different, and there's some trickier ones here with a fraction. Now we have a common logarithm right away, so we're thinking 10 to the power of something equals 10, well 10 to the power of 1, so this is equal to 1 then. Alright, the next one, 2 to the power of something equals 16, well 2 to the power of 4 is 16, so therefore we get that this log base 2 of 16 is equal to 4. Now it's getting a little bit trickier here. So 9 to the power of x is equal to 1/3. Well, the only way that I'm going to get it so that we get this 3 here is to actually square root this 9. So that means it's going to definitely be 1/2. But if I just go 9 to the power of 1/2, that's just 3. So we actually need to reciprocate this 9 as well. And so therefore it's going to be negative 1/2 as our exponent. A similar situation happens here. So 16 to the power of something is 1/2. We have to think, how do we get from 16 to 2? Well, square rooting will get me 4. I can also fourth root though. So the fourth root would get me a positive, or sorry, just a 2, but we want 1/2. So therefore this has to be a negative so that this reciprocates our base. So we get negative 1/4. In our last question then we have base of 5 to the power of x equals 1, well therefore x is 0. So now we can start ordering these logarithms. You need to make sure you actually put the original logarithm. So our smallest one looks like it's going to be this negative 1/2. So we have log base 9 of 1/3. And then we have this negative 1/4. So log 16 of 1/2. Okay, that takes care of those two. And then we've got log base 5 of 1. And log 10. Notice here we don't have to say that the base is 10 as well. It's just assumed if you say log 10, it's a base of 10. And then we have finally log base 2 of 16.